simple harmonic motion. It just moves backwards and forwards in such a way that its acceleration at any instant is directly proportional to its distance from a fixed point. That is what simple harmonic motion is. SHM is the abbreviation. So what does it mean? Acceleration is proportional to displacement. So that means it's equal to some constant times displacement. But that constant must be negative. Because if I have positive displacement and I'm moving in the positive direction and the acceleration is also positive, well, I'm never going to stop. So the constant needs to be negative so that whenever I'm on the positive side of zero, the acceleration is acting in the negative direction. So it's slowing me down until I stop and then I start moving back. And whenever I have negative displacement, acceleration's in the positive direction. Here I am at zero, okay? So at zero, what's my acceleration? Zero, thank you. It's equal to some constant times my displacement. So if my displacement is zero, my acceleration is zero, but I'm just moving in the positive direction. So there's no acceleration, so I'm just moving this way. So I'm now moving this way with a velocity, yeah? But I'm moving in this direction, but the acceleration is in the negative direction. Therefore, slowing down. So I'm slowing down until I stop. Here I am. I've stopped. Mind you, the acceleration is still going this way. So now my velocity is in the negative direction and so is my acceleration. So I am accelerating. Go faster. So faster. Back to zero. Slower. Stop. Turn around. Faster. Zero. Slowing down. Stop. Turn around. Faster. Zero. Slow down. Stop. Now, don't let my demonstration there trick you. You don't actually stop at zero. That was me just demonstrating. That's the point. Okay. So our starting acceleration, the formula that we know, if they tell us it's simple harmonic motion, then we know acceleration is going to be some negative constant. So I make it n squared to ensure that it's a negative constant. So minus n squared x. There's my acceleration formula. And you'll notice it's in terms of displacement. Therefore, I can use d dx of a half v squared. So a half v squared is minus n squared x. Integrate half v squared is minus a half n squared x squared plus a constant. Multiply both sides by 2. I didn't worry about making constant 2 constant. It's still a constant. Now I need some initial conditions to work out my constant. I need some link between displacement and velocity. Okay. When did I stop? Yeah. At the end. Let's just call it A for amplitude. So the furthest point out I got. So when x was equal to A, velocity was equal to 0. Could have said minus A as well, because that also happened. But if you have a look at our little formula, it's x squared anyway, so it doesn't matter whether I used A or minus A. So sub that in. The constant then is n squared A squared. So v squared is minus n squared x squared plus n squared A squared. Oh, I can factorise the n squared. I now get n squared outside of A squared minus x squared. So the velocity is plus or minus, because depending on whether I was going that way or whether I'm going this way, n root A squared minus x squared. Okay, what does that tell me? Remember, velocity squared is greater than or equal to 0, or another way of thinking about that is whatever is under the square root sign has to be greater than or equal to 0. A squared minus x squared is greater than or equal to 0. What do you know? X is in between minus A and A. There was that motion again. I get out to the amplitude, stop, turn around, keep going back till I get to the amplitude, stop, turn around, just backwards and forwards. That is why it's called simple. It's very simple motion, and it's harmonic. Just backwards and forwards, backwards and forwards, backwards and forwards. The life of the particle, there it is, just going between minus A and A. Okay, let's go further, because you are going to be amazed. So, dx to t is equal to I've chosen minus. Okay. It doesn't really matter this one. I could have chose minus, I could have chose plus, because my initial condition that we used was out at the amplitude, and that's when velocity was 0. So it doesn't matter, you know, it's still going to come out to be 0 whether I choose plus or minus. It all comes down to the eventual integration that we're going to end up doing. If I have negative square root, and we're going to turn this upside down, it's going to become an inverse cos function. And if you think of an inverse cos curve, it starts at the amplitude, or the cosine curve starts at the amplitude. So I want to try and match that motion. Whereas if I started at the center, I'll make that end positive, and I'll choose inverse sine. So then it becomes a sine curve, which starts at the center. So I try and match the curve to what my initial conditions are. Turn upside down, there it is. A minus 1 on n root a squared minus x squared, which is inverse cos when we go and integrate. We're going from a to some random point x, because we started out at the amplitude. So inverse cos, another reason for picking that, because look, we get inverse cos of 1, which is of course 0. It disappears. We get a lovely little equation there. Time is equal to 1 on n, inverse cos x on a. Let's make x the subject. And there it is. It's just a cosine curve. A cosine curve is simple harmonic motion. Not the curve, but just imagine you're watching the curve from the side. So you can't see it actually travelling. All you can see is going up and down, up and down, up and down, as it's going along the cosine curve. So in general, what can we use? What can we quote? If they tell us simple harmonic motion, right, we know acceleration is minus n squared x. Okay. V squared equals n squared a squared minus x squared. Can we quote this formula? It's one of those ones, well, how many marks is the question worth? You know? So if it's only 1 mark or something, well, yeah, okay, go and use this formula, if you remember it. But that allows us to find the path of the particle. X equals a cos nt, or sine nt, again, we can quote it. It depends on how the question starts, on whether we start with the acceleration formula or we start with our trig formula. We'll do some examples and you'll see the difference between the type of questions. The particle has period 2 pi on n, same as a cosine curve or a sine curve, exactly the same. Frequency is the reciprocal of period. Now, what's the difference between period and frequency? Period is how long it takes for one complete oscillation. So that's the period. Whereas a frequency is how many oscillations there are per time period. So every second, every minute, whatever it is. Okay. So period, the time it takes for one oscillation. Frequency, how many oscillations per time period. All right, here it is. We've been given the trig equation straight away for displacement. And it says show that it's moving in simple harmonic motion. So all I have to do is show it satisfies that law. Acceleration is equal to some negative constant time displacement. Well, it's a gift question really, because all I've got to do is differentiate it twice and I get minus 36 sine 3t. Oh, well, displacement was 4 sine 3t. So it's minus 9x. It's a negative constant times displacement. Yes, that is simple harmonic motion. Now, if there's some shift happening, it might be a factorization where you get minus 9 outside of x plus 2 or something like that. I mean, that's still simple harmonic motion. It's just, it's not centered at 0, it's centered at 2 or something like that. As long as, the key is the constant with the x. I mean, if it's minus 9x plus 2, the coefficient of x is still negative 9. So, okay, state the period of the motion. Well, it'll be 2 pi on 3, because remember, it's minus n squared x, or another way of looking at it is it was sine nt, so n is 3. So 2 pi on 3 seconds, although they haven't told me it's seconds, I'm just assuming it is. Find the interval in which the particle moves. I've got an equation. I use my knowledge of trig curves now. I don't have to worry about calculus or anything. Find the interval in which the particle moves. Displacement is 4 sine 3t. So what does that sine curve travel between? Minus 4 and 4. So there it is. What's its greatest speed? Oh, well, there's my velocity equation. What's the maximum that trig can ever be? 12. Right? So I don't have to go and use calculus and say, oh, maximum happens when the first derivative is equal to 0 and all that. I can use my knowledge of the trig curves to solve the problem. All right, what we got this time? This time they're giving us acceleration in terms of displacement. So we can assume it's simple harmonic motion because it's in the form minus n squared x. Initially, particles 3 to the right, velocity of 6. Find the interval. All right. Acceleration is in terms of displacement, so I'll use d dx or half v squared. Half v squared will be minus 2x squared plus a constant multiplied by 2. I've got some initial conditions. When x equals 3, velocity is 6. Sub it in, constant is 72. There's my v squared equation. Well, v squared is always greater than or equal to 0. Solving that, I get in between minus 3 root 2 and 3 root 2. The particle is travelling. This is the sort of question where, remember I said, oh, can you just quote the v squared equals n squared, a squared minus x squared? In this case, could I have used that anyway? I could work out n. I'd have to know the amplitude, wouldn't I? So I wouldn't be able to use that anyway. Because how can I tell the amplitude? I mean, that was the question in the first place. So. And greatest acceleration, well, acceleration is minus 4 times x. The greatest displacement is 3 root 2. So therefore, I get minus 12 root 2. So 12 root 2 centimetres per second. I think in this, they're not asking for acceleration, the vector. They're asking for acceleration, the scalar. Well, because that's the thing with acceleration, isn't it? It's both a vector and a scalar. Yeah. Whereas velocity and speed, you've got the two different ones. So when they say greatest acceleration, are they talking about the vector or are they talking about the scalar? So I just write the positive one down. 12 root 2 is the greatest acceleration. Note. Simple harmonic motion. Out of the amplitudes, your acceleration is going to be a maximum because your displacement is a maximum. And acceleration is proportional to displacement. Velocity is 0 because that's where it stops and comes back. At the centre, that's where, whilst I hate the term, velocity is a maximum. Technically, its speed is a maximum because one time it'll be going in the negative direction, one time it'll be going in the positive direction. But that's where acceleration will be 0, again, because it's proportional to displacement. All right. Have a go at 3D and 3F. 3D are the ones that start with the trig, whereas 3F are the ones that starts with the displacement formula.